Noise. Good morning. 4:03 to the HAZ. My coffee. Oh, pre-cal 10, how are you? I have a big zit right on the top of my head, so hopefully that's not going to be too distracting. Yeah, we went to battle and it won the other day, so. But at least I don't have to wear a big old band-aid. It's manageable. Okay. We're talking about, leading up to this point, we've been talking about essentially just like linear graphs, graphs of lines. Some of them go on forever, some of them are fixed, some of them bounce around. So those were graphs, and we kind of just learned how to interpret them, work with them. But what that was ultimately leading us to is really the study of linear equations, okay? And linear equations are different from graphs because linear equations essentially can go on forever, and they're a way of basically quantifying or putting into, I guess, taking a complex situation or a situation where there's a pattern of things happening and basically finding numbers to explain them. Terrible explanation, but let me show you what I mean. So our linear equation is the equation of a line. That's what it is, the equation of a line, and basically we're looking at situations where something's happening that can be graphed with a line. And now we're kind of coming up with an equation for that line so that we can extrapolate, look at future points on that line, or we can interpolate and figure out points within the graph that are maybe not data points. You've seen some of these concepts in science, and we're just going to start really formalizing them. So, slope of a line. The most basic equation of a linear equation is just y is equal to x, okay? This is the most basic linear equation we can come up with, okay? And we call it a linear equation because whatever graph it's going to produce is going to be linear. It's going to be a line. So we're just dealing with line graphs. Once we move into pre-cal 11 and pre-cal 12, we go from talking about line graphs to now quadratic graphs. And quadratic graphs are going to be graphs that have squares in them. Okay, that's quadratic. So linear graphs are never going to have a squared term in them because that would make it quadratic. So the most basic equation. Now what I'm going to do is any equation has random inputs. I'm just going to choose random inputs for x, okay? -1, -0, 1, 2. I'm choosing my inputs. Now let's see what my graph outputs based on this equation. Well, if y is equal to x, then y is equal to x. And if I were to graph this on my Cartesian coordinates, where I have positive x, positive y, negative x, negative y, if I were to graph this at 1, 2, -1, -2, -1, -2, 1, 2, well basically y is going to equal x, at 0 it's 0, and this will be a line that goes on forever in each direction, and I can calculate any y by inputting whatever x I have. That is our most baseline linear equation. So let's now talk about the equation of a line in the general form, okay? So I'm going to leave this up so we can kind of think about it. Actually, I'm going to erase that. So I'm going to put it up right here. So the general equation of a line, and you're going to learn to love this equation because it comes up so much in the future of math, is this. Okay, I'm going to, y is equal to m times our variable x plus b. B you can think of as our starting point, but we call it our y-intercept, okay? So m is something we call the slope, okay? The slope is basically what is the angle that my linear equation is going up or down. Like, what is the rate? Is it going up really fast? Is it going down really slow, gradually? The slope is basically what is the rate of change of my equation. And then B, the y-intercept, is basically where does my linear equation, where does it cross my y-axis? So for that graph that we were just doing, of the most basic linear equation, y is equal to x, which if I were to put it into this form, so that equation, y is equal to x, well, in this case, my slope is 1, because it's 1x, there's 1 in front of the x, and my b is 0. So if I was to use this form, I could rewrite this as 1x plus 0, okay? If I cannot have a 0 slope. If I have 0 slope, excuse me, I'm basically a flat line. If I have a 0 slope, I'm a flat line. I'm not doing anything. I'm just cruising along. And if I have 0 for my y-intercept, it means that I'm literally crossing the y-axis at 0, at x is equal to 0, or at y is equal to 0, sorry. So this is the equation of y is equal to x. And then I can calculate the angle the slope, the rate of change of this graph. And if I did that, I would find that it's 1. And we're going to talk about how we calculate slope. So, for this unit, we're really just going to be working on calculating m, calculating b, and sometimes they're going to give us m and b in different ways, and we're going to calculate what the equation of our line is. But in order to do that, we need to first learn how to calculate slope. So let's start talking about m, about slope. Okay? So, m is slope. I'm going to put these terms right here. And b, y-intercept. Y-int, y-intercept. Okay? So, slope, m. M is, the slope is our rise, our y change, our rise over our run, which we can explain as change in y. That triangle just means change. You'll see it in mathematics, it means delta, change. A triangle just means the change. So the change in y over the change in x over the same period. And you can think of it as even more so, well, we'll talk about this in a sec. So here's how we calculate slope every single time, okay? Every single time. Okay, here we go. So let's say I have two lines. Here's the first line. First line equation goes like this, and it goes forever in each direction. And let's say I have a point here and a point here that I know for sure what the coordinates are, okay? And let's say that I know that this point is 0.52, so my x coordinate's 5, y coordinate's 2, and this one, let's say it is -1, -3, we'll say. Okay, -1 in the x, -1 in the 3. So that's my first equation. And my second line that I want to figure out the slope of, let's say it goes like this. It's a little steeper, and it goes like this, and it has a data point here, we'll say that is 2, -4, and I've got one here, way up here, that is -3, 3. Okay, there we go. I got two lines, I know they're linear, they're straight lines, and I know that they go in either direction forever, which means that they have an equation that I can use to calculate them, because that's why they can go in forever. So how do I calculate slope of both of these lines? Well, every time I'm going to calculate slope, I am going to take my more positive x coordinate, okay? So basically, whatever coordinate is further to the right, that's where I'm going to start. So let's start with the red one. So let's do the slope. I'm going to call this one red slope because it's my red line, okay? Slope of my red line. I'm just telling myself this is the slope of my red line. That's what the sub means. You don't have to do that. So here is the equation for slope. Let me put it up before I actually jump into this. Slope, based on this, is my further right y-coordinate minus my y-coordinate to the left. So it would be, in this line, my y-coordinate that's furthest to the right is this coordinate, and it has a y of 2. So that would be like my y2. And then the other coordinate, the one that's further to the left, that's going to be my x1, y1. Okay? And my y will be -3. I'm being confusing, so let me just finish this up. So I have x2, x1. Okay, so my change in x is going to be the change in my x. So it's going from -1 to 5. That's a change of 6. My change in y, we're going from -3 to +2. That's a change of 5. But my coordinates that are further to the right are going to be my x2, y2. And then the ones that are further to the left are going to be my x1, y1. And same on my green line. Whatever's further to the right is going to be my x2, y2. And whatever's further to the left is going to be my starting point, my x1, y1. So basically, we always look at linear equations as starting on the left, finishing on the right. And we always want to take our right coordinate minus our left coordinate. So if I do that, this is important right here. That's the equation. You want to write that down. So if I do that, and I'll do that up here, the slope of my red line is my y2 minus y1. Well, there's y2. It's 2 minus my first y-coordinate, which is -3. So it's minus -3, which gives me a 2 minus -3 is 2 plus 3. It's 5, which is the change. I went from -3 to +2. I changed by 5. That's perfect. And then my x2 is my 5. And my x1 is -1. So it's 5 minus -1. And when I do that, I get 5 divided by 5 plus 1 over 6. So the slope of this line is 5 over 6. That's the slope of my red line, 5 over 6. M is 5 over 6 for the red line. Now let's do our green line. So our green line, we're going to use the exact same process. We're going to take our data point that's further to the right, and we're going to subtract it from my data point that's further to the left. So using the exact same equation, y2 minus y1, so rise, the change in the rise over the change in the run. So if I do that, in this green line, my y2, the further to the right, is -4. And then my y1, oh, this should be y1 there, sorry. My y1, which is my y-coordinate further to the left, is 3. So -4 minus 3, divided by now my x2, which is 2, minus my x1, which is -3. So minus -3. And so what is -4 minus 3? -7. Over, what is 2 minus -3? Well, 2 minus -3 is 2 plus 3, which is 5. So in this case, my slope is -7 over 5. Now, what is the biggest difference between this slope and this slope? Well, the one in red is a positive, it's not negative. The one in green is negative. So what that tells us is any time that our line, or a linear graph, is going down from left to right, we're going to have a negative slope. Down from left to right means negative slope. Up, if we're going up from left to right, we're going to have a positive slope. That's it. That's how it works. As long as we're not messing with our Cartesian way of looking at things. So that's that. That's how you calculate slope. And we can play around with this stuff, but this is our introduction. And in the next video, we'll talk about Y-intercept and kind of calculating that. But this is just an introduction. We'll go from there.